In section 3.1, our objective is to use derivatives to find critical numbers and the maximum and minimum values of a function on a closed interval. Extrema on an interval. Extrema means the extreme values. Those are the minimum and maximum values of a function. F of c, notice f, that's a y value, is the minimum, can be described as absolute or global minimum of a function f on an interval I if f of c is less than or equal to f of x, meaning that y value is less than or equal to all other y values for all x in the interval. Basically, just think of the lowest y value in the function. Similarly, f of c is the maximum or absolute or global maximum of f on an interval if f of c is greater than or equal to f of x for all x in that interval, meaning the greatest value, or looking at the graph, the highest y value in the graph. Let's practice identifying maximum and minimums, and remember, those are the y values. Find the absolute extrema for the graph of each function. Give the location x values for each. So let's begin by looking for the absolute minimums. Looking down to the lowest point in the graph, that would be here, is at 1, 2, 3, 4, 5, 6, 7, -7. So we can say the absolute minimum is -7. The location, that's the x value. We'll say that's located at x equals -1. We have to go to -1 to get down to the minimum of -7. How about the absolute maximum, or just max for short? That is, well, let's look to the top of the graph. Well, I see the graph goes to the highest point at 6. 6 is the highest that the graph goes. So the absolute maximum is 6. Where is it located? That's at two different places. One location is here, the other is here. -7 and 1 at x equals -7 and at x equals 1. So see that an absolute max is the highest value, even though it can be located at multiple places. How about this graph? Well, I look for the lowest point, but I see that there's an arrow indicating that this graph keeps going down. So the absolute minimum of this graph does not exist because there is not a lowest point that the graph goes. Looking for an absolute max, I look to the highest, and because there is a hole indicating that while there may be a limit to the function keeps trying to reach that value and never gets there. So the absolute maximum also does not exist. Let's talk about the extreme value theorem. The extreme value theorem tells us that if a function is continuous on a closed interval, then the function has both a minimum and maximum on that interval. Let's take a look back at the graphs to talk about what that means. So notice this first function is on a closed interval. The lowest that this function goes is -7. The highest that this function goes is approximately 6. So it's the closed interval, -7 to 6. Now, it's not a continuous function unless I fill this hole in. So let's pretend it's continuous. If it's a closed interval, meaning that it can't keep going forever, it stops at -7 and it stops at 6, there has to be a highest and lowest value, y value of the function, no matter what the function looks like. Whereas here, we do not have a closed interval. This is an open interval because the domain of the graph starts at -2, but it doesn't include -2, and then it keeps going forever because of this arrow. So here's a closed interval, And if it's a continuous function, we have to have a max and a min. Here on an open interval, we don't have them. We might have them, but we don't have to have them. So the extreme value theorem tells us that there has to be extreme values for a continuous function on a closed interval. Let's take a look now at relative extrema. Relative extrema are the relative or local extreme values. If there is an open interval containing c on which f of c is a minimum, then f of c is called a relative minimum of the function. Basically, what that is saying is if we can see on either side of a point and we see that it's the lowest relative to the points around it, then it's called a relative minimum. It may not be the lowest point in the entire function, it's the lowest relative to what's nearby. Similarly, if there's an open interval containing c on which f of c is a maximum, then f of c is called a relative maximum of f. So looking at a hill, we have a relative maximum because it's a high point relative to the points on either side. Let's take a look back at the graphs and now find the relative extrema for the graph of the function. Looking at the first graph, finding the relative minimums, here is a low point. I can see on either side the points are higher. This is the lowest point for the points on either side. That's the y value 0, so the relative minimum is 0. Where is it located? That's at x equals -5. But that's not the only place where we have a low point relative to the points on either side. This is also a low point relative to the points on either side. So that is -7, and that's located at x equals -1. Yes, it was also an absolute minimum, but because I can see on either side, it also is a relative minimum. Do I have any more? Here's another low point. -2 is what that low point is. It's located at x equals 2. And one more I see. Here's a low point relative to the points on either side. That is -5 at x equals 5. So we do have 4 relative minimums in this graph. How about relative maximums? I see a high point here, and I can see on either side. Therefore, this y value of 2 is a relative max. Where is it located? At x equals -4. I have another relative maximum here. I can see on either side these points are lower. This is high relative to the points around it. That's the y value 6. Notice that was also an absolute maximum, and that's located at x equals 1. Now remember earlier I filled this in to talk about what if the function's continuous, but actually it's a whole. So I don't have a relative maximum here. I don't have a relative maximum here because I cannot see on either side of that endpoint. Same with this endpoint. I cannot see on either side. I can't see on the left side, only on the right side. I have to be able to see on both sides to see that that's a high point relative to the other points nearby. How about this graph? I do have a relative min. It's -2. So let's say the relative min is -2. Where is it located? At x equals 0. And a relative max is 1. Remember, these are the y values. And that's located at x equals 2. It's important to note that for relative extrema, we must be able to see on both sides of the point. Remember, relative to either side, it's a high or low point, which means these can not occur at an endpoint.